So let's have a look at the seasonal variations of the wind-driven circulation. Very, very complex transition, and I try to explain it. So first of all, what we're talking about in terms of wind-driven circulation are currents, horizontal currents, horizontal movements that extend from the surface to a depth of about 2 kilometers, 1 to 2 kilometers. And they are shown here. These arrows show the current patterns. Okay? So the easiest thing to approach the system, so first of all, what's shown here are the currents and every 2 months. The top left, I activate the mouse, top left in January. Then below that, 2 months later in March. Then the one below in May. And then you move over to the top right. You have it in July, then in September, and then you November, and then you jump back to January. So it's a cyclic feature. It repeats every year. So you approach that best if you start thinking about the northeast monsoon. Because the northeast monsoon, which is here represented by March, is a situation which is similar to the other oceans. Okay, and we already talked about the circulation in the Pacific Ocean, where you have northeast trade winds near the equator. Okay, so what happens during that time? You actually get you get actually a subtropical gyre developing in the northern Indian Ocean. Also a mini one here in the Bay of Bengal. Okay? South of the equator, you always have a subtropical gyre, which sort of is cut off here in half. Okay, you have that year round. The seasonal variations you only get, in the northern Indian Ocean. Okay, and then in the other extreme of having the southwest monsoon with the dramatic change of the wind direction, actually creates a large gyre, which actually is centered over the equator. Okay, you can see here on the September image, and it has a strong boundary current which actually runs across the equator. Somali current. Okay, that's the feature. Okay? And between these two opposite phases, you have a certain transitions which includes countercurrents, and equatorial jets as well. So now in this situation in the Indian Ocean, the northern Indian Ocean, it's actually very tricky to predict where things go. Okay, because if you have a fish turtle drifts over a long time, okay, it's hard to predict because there are these seasonal changes. All right, so this is very important to know, to remember. There are these seasonal changes. And associated with the change in the wind direction, you also have seasonal coastal upwelling systems. Okay, so you remember that you get coastal upwelling if you have winds in the northern hemisphere, which blow along the coastline, and the coastline has to be on the left with respect to the wind direction. And in the southern hemisphere, it's the opposite direction. Okay, and here the seasonal upwelling systems are also illustrated here in this graph. Okay,